They're mysterious, massive, and might just be portals to other universes. So here's everything we know about them and what we want to know most. What are the chances that somewhere out there in the vast expanse of space and time, there exists a version of you living a completely different life, making different decisions, experiencing a different reality? Sounds far-fetched, doesn't it? Well, modern physics suggests that it might not be as crazy as you think. And the key to unlocking these alternate universes could lie in the most enigmatic objects in the cosmos: black holes. Einstein's theory of general relativity tells us that black holes can be connected by what's called an Einstein-Rosen bridge, otherwise known as a wormhole. Wormholes are hypothetical tunnels that connect to points in space-time. While they haven't been observed directly, they remain a fascinating possibility in the world of theoretical physics. This is a theoretical framework that attempts to unify the principles of quantum mechanics with those of general relativity. The term multiverse refers to the hypothetical existence of multiple universes. It's a concept that is often associated with certain interpretations of quantum mechanics and string theory. In many multiverse ideas, these universes are infinite in number, and they may have their own distinct laws of physics. However, scientists continue to explore this intriguing possibility. Some versions of the multiverse suggest that universes can collide or interact with one another, giving rise to the possibility of interdimensional travel. Here, gravity becomes so strong that it tears apart any matter that ventures too close. As it gets closer to the singularity, the object is subjected to extreme temperatures and pressures. It is compressed and heated until it is nothing but a thin stream of subatomic particles. They use advanced mathematical models to simulate the behavior of matter under extreme conditions, such as those found near a black hole. Scientists are still trying to understand the role that black holes play in the evolution of the universe, and how they affect the distribution of matter and energy in space. They are also working to develop new technologies that will allow them to observe black holes in greater detail and study them more effectively. These simulations can provide insights into the physical processes that occur inside a black hole and help scientists test their theories about the nature of gravity and the early universe. Let me know in the comments below. Thank you for joining me on this journey through the cosmos to explore one of the most perplexing mysteries of the universe. If you enjoyed this adventure and want to keep learning about the greatest secrets of space, hit subscribe and join our cosmic quest. Together, we'll unravel the mysteries of the cosmos, one mind-bending discovery at a time. So what are you waiting for? Join us today and let's explore the wonders of the universe together. As an object approaches a black hole, the gravitational force becomes incredibly strong, making it difficult for spacecraft or other objects to escape its grasp. This means that it's currently impossible to send a manned mission to explore a black hole up close. Another challenge is the fact that once something crosses a black hole's event horizon, it can never be seen again. This makes it difficult to study what happens inside a black hole and has led to speculation about what might lie beyond the event horizon. Additionally, the intense radiation and energy released by black holes can damage equipment and make it challenging to collect data about them. Despite these challenges, scientists continue to find ways to observe and study black holes from a safe distance using telescopes and other instruments. Finally, at the very center of the black hole lies the singularity. It's a highly speculative concept that has emerged from the fields of theoretical physics and cosmology, while it remains purely hypothetical. It's an intriguing possibility that captures the imagination of scientists and space enthusiasts alike. Some physicists have suggested that black holes could be connected by wormholes, which are hypothetical tunnels that traverse the fabric of space-time. Others have proposed that black holes could give rise to baby universes, each with its own unique set of physical laws and constants. However, there is currently no direct evidence to support these ideas. Exploring this concept faces significant challenges, including the immense gravity near black holes, the difficulty of observing what lies beyond their event horizons, and the potential for radiation to damage equipment. Nevertheless, scientists continue to investigate the properties of black holes and the nature of the universe in an effort to better understand these enigmatic objects and the possibility that they might serve as gateways to other universes. It's a region of infinite density where all the matter that has been consumed by the black hole is crushed. Our current understanding of physics breaks down at the singularity, and it remains one of the biggest mysteries of the cosmos. So a black hole in one universe could potentially connect to the birth of another universe in the multiverse. They use telescopes to observe the light and radiation emitted by matter as it falls into a black hole. In 2017, a team of scientists captured the first ever image of a black hole's event horizon. The image shows a bright ring of light surrounding a dark central region, which represents the singularity. These observations have helped scientists better understand the behavior of matter near a black hole and have provided valuable insights into the nature of gravity. By studying this radiation, they can learn more about the properties of the black hole, such as its mass and spin. Gravitational waves are also a valuable tool in studying black holes. When two black holes merge, they emit a burst of gravitational waves, ripples in the fabric of space-time that carry information about the black holes themselves. By detecting these gravitational waves, scientists can gain insight into the behavior of black holes and the nature of gravity. One idea that emerges from quantum gravity is the notion of bridges that extend beyond the singularities of black holes. When a black hole evaporates, it releases a burst of energy that could hypothetically trigger the formation of a new universe with its own set of physical laws. These ideas are highly speculative, and they remain controversial within the scientific community. Because of their immense gravity, black holes distort space-time, creating a deep and wide abyss that warps the fabric of reality. The event horizon is the boundary that marks the point of no return, separating the known universe from the unknown depths of the black hole. Inside this boundary, the laws of physics as we understand them break down, and the very concept of time becomes meaningless. As an object approaches the event horizon, it is pulled towards the singularity by an intense gravitational force. This force stretches and distorts the object, pulling it into a thin, noodle-like shape known as spaghettification. Eventually, the object is pulled past the event horizon and disappears from view, leaving behind an ominous silhouette against the backdrop of glowing hot gas and plasma. These bridges serve as pathways to other universes or alternate realms of reality. Some physicists even speculate that the Big Bang, the event that is believed to have marked the beginning of our universe, occurred inside a black hole in another universe. Proponents of this idea argued that it could help resolve some of the biggest mysteries in cosmology, such as the universe's beginning and its ultimate fate. Wormholes could theoretically connect distant regions of our universe, or they could even connect to other universes entirely. This idea might sound like science fiction, but it's actually rooted in the mathematics of general relativity. However, we don't know whether wormholes actually exist or if they're merely a mathematical curiosity. But before we dive into this tantalizing possibility, let's first take a closer look at these cosmic enigmas. In other words, it's a shortcut through the four-dimensional fabric of the universe. If wormholes do exist, they could potentially connect to black holes, allowing matter to travel from one to the other without ever crossing the intervening space. To understand how this works, let's imagine a piece of paper as a two-dimensional surface representing space-time. 2 points on the paper can be connected by a straight-line segment, which represents a path through space-time. But if we fold the paper in such a way that the 2 points touch, we create a sort of wormhole. Now, if we were to place a small object at one point, it could fall through the wormhole and emerge at the other point without ever traveling along the line segment that connects them. Similarly, in four-dimensional space-time, a wormhole could connect to points that are very far apart, allowing an object to travel between them almost instantaneously. Black holes are regions in space where gravity is so strong that not even light can escape their grasp. Our current understanding of physics breaks down at the singularity, and it remains one of the biggest mysteries of the cosmos. Black holes warp both time and space. Time slows down dramatically near a black hole compared to an observer far away from it. This phenomenon known as time dilation means that someone who spends a lot of time near a black hole could potentially return from their journey only to find that much more time has passed on Earth. Now imagine falling into a black hole. As you approach the event horizon, the gravitational forces would start to stretch your body in a process called tidal stretching. The gravity on one side of your body would be significantly stronger than the other, and it would literally pull you into a long, thin shape like spaghetti. They are born when massive stars collapse at the end of their lives and can grow to become supermassive, millions or even billions of times the size of our sun. Once something enters a black hole, it crosses a boundary known as the event horizon. This is the point of no return, the threshold beyond which escape is impossible. At this point, gravity becomes so intense that it tears apart anything that ventures too close, stretching it and crushing it until it's nothing but a thin noodle of sorts, a process known as spaghettification. At the heart of a black hole lies the singularity. It's a region of infinite density where all the matter that has been consumed by the black hole is crushed. But what does this have to do with alternate universes? According to Einstein's theory, a wormhole is a tunnel-like structure that connects to different points in space-time. The concept of black holes as portals to other universes goes beyond Einstein's work. It delves into the realm of quantum gravity. Now, you might be wondering what a multiverse actually is. Some cosmologists have gone even further and proposed that each black hole in the universe creates its own baby universe. Before we go further, it's important to note that there is currently no direct evidence to support the idea that black holes are gateways to other universes, or that alternate universes even exist. So what exactly is going on inside a black hole? Once inside the event horizon, the object continues its journey towards the singularity. Despite the challenges, scientists are constantly working to unravel the secrets of black holes. One of the most exciting developments in black hole research has been the ability to image them directly. In addition to these observational studies, theoretical physicists are also making significant progress in understanding black holes. Despite these advances, much about black holes still remains a mystery. So what are the biggest challenges in exploring black holes? One of the biggest challenges in studying black holes is the extreme gravity near their event horizons. So are black holes gateways to other universes? The idea of black holes as gateways to other universes is fascinating. So what do you think? Could there be other universes out there just waiting to be discovered through the mysterious portals that are black holes?